The next application of op-amp what we are going to discuss is a comparator. So till now whatever applications of op-amp we dealt with, all having a feedback from output back to input. So here it is different to that. It doesn't have a feedback from output back to input. So a comparator circuit actually compares the signal voltage on one input of op-amp with a known voltage called reference voltage on the other input. See, you will be applying inputs to both the terminals of the comparator, and one we will take as a reference and other one we will compare against the reference. Suppose here you are applying an input signal to negative terminal and positive terminal you are keeping as the reference. So when the input terminal voltage at the inverting is greater than the reference voltage, output will go to negative level, and if the input voltage at the inverting terminal is greater than the non-inverting voltage, output will go to negative level. If it is greater, output will go to positive level. So output will be a digital representation whether your input voltage exceeded reference voltage or not. That means either output will be a plus voltage like a square plus and minus, plus voltage plus V side, we will represent it as a plus saturation voltage. So output will stays at a high voltage when non-inverting terminal voltage is higher than inverting terminal, and it switches to lower voltage level when non-inverting terminal voltage is lower than inverting voltage. So this type of circuits will be used in digital interfacing, Smith triggers, voltage level detectors, oscillators. Many applications are there, comparators. See, whenever we are taking a circuit for doing mini project and all, at least one or two comparator will be there. Most of the circuit will be containing. So I'll explain you one again the detailed operation of a simple comparator. See, this is a comparator circuit. Now just see here, inverting terminal I am grounding. So the voltage at the inverting terminal, say this voltage is V1, is equal to 0. Now input I am applying to non-inverting voltage, it is a sine wave. Say the voltage is represented, I am going to represent it by V2. It is represented by V2. So V1 is the voltage at the non-inverting terminal, inverting terminal, V2 is the voltage at the non-inverting terminal. So non-inverting terminal voltage equal to 0. So I'll just draw the input here. This is my input, that is V2, and just think that this is going to be the reference voltage. This is the reference voltage and it's nothing but it is equal to 0. So now we are going to compare these two voltages with, one is 0 and other is a sinusoidal signal. So I just mark the levels here for your understanding. Okay. Now see, this is V2 and 0 voltage, 0 potential representing is nothing but the V1. Now here, this is the time axis, fine. Now see, non-inverting voltage is this, positive in this time duration. Inverting voltage is 0, which is higher, V2 or V1. So V1 is lower than V2. V2 is higher. V2 is connected to the non-inverting terminal. So plus voltage is higher. So I can write it as plus. I can write it as plus V side. A plus voltage will come up the output. Say this is plus V side. Now see here, 0 voltage is greater. The negative voltage is V2 is now negative. So 0 is greater than that. That means 0 voltage at 2 is greater than that. So output will go to minus Vsat. Here plus voltage is greater than the 0 voltage. So it is go to plus. So it will repeat like that. This is minus Vsat. So just remember here, if the voltage at the non-inverting terminal is greater than inverting. Inverting terminal, remember your output VO will be non-inverting plus is, just remember non-inverting is plus, inverting is minus. Plus is higher than minus, so your output will go to plus Vsat, positive. And if non-inverting voltage is less than inverting terminal voltage, then VO goes to minus Vsat. VO goes to minus Vsat. So that is the working of a basic comparator. Now depending on the voltage potential, you have to see whether it is inverting or non-inverting voltage is greater. According to that, you have to draw plus Vsat and minus Vsat. See, the same thing I will draw with another example and tell you. Now check here this circuit. You are applying in a sine wave to the inverting terminal. Non-inverting terminal, you are applying a DC voltage of 2 volt. So sine wave, say 5 volt peak I am applying to the inverting terminal. Non-inverting terminal I am applying a 2 voltage peak. So this Vi is the input you are applying to the sinusoidal, and the other one is the reference voltage. Now see, this is a 2 volt. Till this point, when I am considering, the 2 volt is higher than the sine wave. 2 volt is plus. So I can draw this as, see, till here, volt is higher than the sine wave. So till that point, non-inverting voltage is higher, so it should be plus Vsat. Now see here, sine wave is higher than 2 volt. Sine wave is in the inverting terminal, so minus voltage is higher. So till this point, so I can draw till that point, that voltage should be minus Vsat. Minus Vsat. Now see here, to this point, 2 volt is higher than the sine wave. So 2 volt is coming in the non-inverting terminal. So there it is, should be plus Vsat. It's same line, okay? Plus Vsat. Now till this point, you see again, the 2 volt is coming lower than the sine wave. Sine wave was the inverting, so it should be minus Vsat. So this is the way you are getting a comparator output. Remember, for the comparator only 2 levels are there, either plus Vsat or minus Vsat. In Vsat will be around the supply voltage what you are giving. It will be around that value. Now going back to see this circuit. Here this is the minus terminal. Here a voltage is coming this 12 volt away and some input you are applying. So this is, say, take it as the reference voltage. This point voltage, take it as reference voltage. So this point voltage I am writing as reference. Now what is the reference voltage here? You can calculate it, right? V reference should be equal to, that is the voltage across 10 kilo ohm resistor. How much it is? By using voltage divider rule. What is the current in this loop? Coming here, no current will flow here, only one current. So current is 12 divided by 10k plus 10k, 20k, multiplied by the resistance. Resistance is 10k. So it should be equal to 6 volt. So the voltage V reference coming here are 6 volt will come here. Now whatever be the input, you will compare against the reference voltage 6 volt. If your input is greater than the 6 volt, output will be plus VZ. In that time, plus is connected to the LED, LED will on. So remember, if Vi is above V reference 6 volt, LED will be on. See, here it is just opposite. You are connecting the reference voltage to plus terminal. So this is the reference voltage, same only will come, same equation, same way. So 6 volt will come at this point. If the inverting terminal voltage is lower than, because it is no inverting, lower than 6 volt, LED will be on, because LED is positive coming here. So when the output is plus VSAT, only LED will be on. So that means 6 volt should be higher than V input. So 6 volt, that means the V reference should be greater than Vi, it should be plus volt. Here opposite case, Vi, if Vi is greater than the V reference, because it is inverting, your output should be plus VSAT. So that's about the comparator, and next we will discuss the Smith trigger.